just launched this past December. This is going to be a tutorial session, so if you're not coding or if you need any of the basics of the basics involved in the SDK, I advise you go ahead and look at developer.altvr.com, and that will give you information on how to get started. This is a little bit of this is a coding sample, so if you're not a coder, I don't know how much you'll be getting out of this, but you're welcome to stay and hang out in any case. Yeah, Soren, you want to take it away?
Yeah, and I would also say that while this is about coding, I'm keeping this very, very simple. So even for people that are just starting out programming, this might be a good insight into how I was thinking when I was building a tic-tac-toe game. So this is really meant as a beginner example. So, and so first up, I want to say that you can find all the samples in our GitHub repo. And these slides are also going to be available on the link that I'm providing here. We're going to be sharing the links in Slack as well. So those of you that are on Slack, you'll be able to see this and go through this again afterwards. And then the final tic-tac-toe app, which is the one you can see all the way. Where's my laser pointer? Oh, anyway, all the way to my left over there. That is the game, the final deployed tic-tac-toe game, so you can play with that. As I'm going through this tutorial, I'm going to have the tic-tac-toe game up here. I would like if you guys don't try to click on it, because at some point, if you click on it the wrong way, it's actually going to break, because I'm showing you the development steps, and in development, there are bugs in it. Okay. And about the presentation here, so I've set this up I'm using the SDK Playground for the one reason, as the template for this space, for the one reason that it has real-time lighting in here. Not all of the spaces do, and this one I knew did, so that the SDK things that we're building here, they look much nicer with, you can see the light changes as the cube is spinning underneath the table here, like right down there. So I have set up a table. I've set up actually 2 spots, one over here and one over here, that I'm going to be deploying live to an OpenNode server, actually to 2 OpenNode servers. I'm going to be ping-ponging between each of the deployments. And so you'll see me just do live deployments. And if it takes a little while, it takes maybe 30 seconds to a minute for each deploy. So there might be a little bit of break here and there for some questions. And so when I do my development myself, I actually don't use deployment to a server. I just run on a localhost deployment. But this is, for showing live to you guys, this was the safest way I could find. And so what I recommend before trying to go through a tutorial like this, we're going to be recording this, and you'll be able to access it on YouTube afterwards. If you're going to go back and do this, you should probably go and get the Hello World installed and deployed first. We have instructions, the build and run instructions that you should hopefully be able to follow. And then there's also instructions on how to use Visual Studio Code for easy development. So, and with that, I'm going to go through the steps that I've actually done. Step 0, I took the whole folder for Hello World and just made a copy of it, and I renamed it Tic-Tac-Toe, just so that I didn't modify the existing Hello World. So that's the first step. And then I went in and I did a find for every mention of Hello World and replaced it with Tic-Tac-Toe. So over here on my left, you can see the Tic-Tac-Toe text above the spinning cube. This is because, so the original Hello World sample has the same cube and the text is just as Hello World. So I was searching for hello, and I found Hello World without space, Hello Dash World, Hello Space World. So I just replaced all of those. And then I also went in, I didn't do those changes in tasks.json and launch.json. What I did instead was I copied the tasks and launch.json tasks. There's a field for in tasks and a field in launch that I duplicated so that I could both have hello world and tic-tac-toe, and I would be able to build and run those at the same time. So now I'm going to start on the actual programming steps. So if you see here under the table over here, let me just get my laser pointer back.
Hello.
Hello. If you see over here on this spinning cube that is spinning like crazy right now, you can see that I have whenever the text spins, the cube spins with it. But we couldn't really have that. It's because the text is the parent of the cube, so we kind of have a hierarchy where the cube is kind of glued to the text. So whenever the text spins, the cube spins. But we can't have that because the table can't be spinning as we keep the game going. So I just changed it so that the cube, as you can see here, where it says parent ID, this.text.id, I just deleted that line out, and as you can see on the right, now the text spins, but the cube does not. There was actually one other thing that we had to do that is a little bit complex, and is a workaround for an MRE SDK bug that Eric is looking at as we're speaking, that when I did this parent change, we had to make some changes to wait for the animation to be created before we started playing it. I don't really think I should go into this detail because it's a bug and we're going to get it fixed, and it's not something you should have to do. So I'm just going to skip right past that step. So next up, this is where we're going to start to turn this into an actual game. Instead of having just one cube, we need 9 cubes, right? Tic-Tac-Toe, there's 9 fields, but it's really not at 9 cubes on a straight line. It's a 3x3 grid. So I had to create a loop to go through it. But the first thing I did was actually, because it was underneath the table, I moved the text up from 0.5 to 1.5. So now you can see the text is a little bit higher up here. You see the text moved from here to be up a little bit further. And then I did the loop to go through and create the cubes. So I actually did 2 loops, one on X, which is going from this way, and one on Z going from this way. So I looped 3 times on this and 3 times on this to get the 9 cubes. And I'm mentioning here that Visual Studio Code can auto indent for you. I'm going to tell you why in a second. As you can see here on the code here, right up here, that I have for let tile index equals 0 to less than 3. So basically, the for loop is it goes through the index and does 0 and plus 1 becomes 1, plus 1 becomes 2, and then until the less than 3, as long as it's less than 3. So this basically means we go tile index from 0, 1, and 2, 0, 1, 2 on tile index X. Then inside this loop, we do another loop where we let the tile index Z go from 0, 1, 2. So basically it goes for X is 0, create 0, 1, and 2 for Z. Then we make X1 and go 0, 1, 2, then X, 0, 1, 2. And so we also had to make a change to where do we place each of these cubes, because we can't just place them at the same spot. That's why I have the line that says the position is now changed to be tile index X minus 1 and 0.5 and tile index Z minus 1. Because remember, tile index X went from 0, 1, 2, so it basically becomes minus 1, 0, and 1. Just to get it all centered around, so the middle is 0, 0. And then I moved it up so that its Y is 0.5, so it's above the table. So that is the stuff we did here. And then one more thing I had to say is also that all the text in blue up here, those are lines that haven't been changed, but they have been indented in. That means we basically moved them in a little bit because it's inside the loop. It makes it a little bit easier to see, and I was just using Visual Studio Code to automatically format this so that whenever it's inside the bracket, it gets indented in further. Then the one other little change I did was you had to add the close brackets after it's done creating the cubes and adding the behaviors onto the cubes. I added in the 2 lines for closing bracket to mark the end of the loop. And then I did the start animation spin was put in the middle of all this cube creation, but we don't really want to start spinning the text 9 times. We just wanted to start it once, so I just moved it outside of the loop. And then there was one bug in this though, was that I don't know if you saw, but it only actually highlighted. It only actually highlighted 1 out of those 9 cubes. This was because, and over here in the next version, we actually do have all the 9 cubes are highlighting properly. This is because the Tic-Tac-Toe, remember, it came from the Hello World. The Tic-Tac-Toe class has a member that says the cube. The cube is currently, the cube is what we're doing everything on. But there are 9 cubes now, so we can't just say this is the cube. So what all the code said in this, the old sample was on my cube, make it spin, on my cube, make it bigger. But every one of those 9 cubes says, I'm the cube, and only the last one was stored. So we changed it so that the class does not store, the Tic-Tac-Toe class does not store 1 cube. And instead, we changed everywhere where it says this cube to just say the cube that's just created. So every one of the places up here where it says cube.create animation, for example, before it said this cube create animation. By making it the cube that's inside the loop that was just created, we make sure that all 9 of them now work. If you can see here, all 9 of these now highlight just fine. And so you can see we need to, right now when you click on it, it just spins the block. And that is not really, that's not really what we need for the game. We need to actually start to put down some game pieces on the board, right? It's not much of a board game without board pieces. So I'm going to create these as primitives. And the first thing we need to know is that AltspaceVR has a, it knows about primitive shapes. Can I just say one thing, that on the next couple of deployments, I would rather you guys didn't touch it because there are bugs in it. So if you click on it, it might break some of the things I'm going to try to show off. We have a primitive shape that we're registering, or that we want to make sure that we import from the Mixed Reality Extension SDK. It basically says we want to know what a primitive shape is. And so we need to then also change what happens when you click on something. So instead of it being spin an object, we're changing it to be when you click on something, it needs to start, it needs to create an object. And I don't know why it's not actually doing it right now when I'm trying to click on it. So we have the objects here. I can't click on them for some reason. Well, I'm going to show you in the next step. It's probably going to start working when I do the next deployment. So what we're doing here is we're taking the position of the cube. You can see up here, it says the game piece position. We're calculating that by taking the cube's x, y, and z coordinate, but we're moving it up on y just a little bit. That basically means that it's going to be creating this object a little bit above the cube. Remember, y is up in our coordinate system in AltspaceVR, so moving it on y means moving it up. And the primitive we're creating is a cylinder. It is about 20 centimeters on y, so about this big, I guess, about this big. And then it has a radius of 40, so about this big. And you should be able to see here when I click on this, it creates a spoiler. It creates a cylinder like that. So the sample that you had here, it actually shows you creating only cylinders. But the next step is we need to be able to take turns between cylinders and then creating X's. So X and O, because you can't just put down O's. So right now it takes turn X, O in the sample. And I do that by creating a game piece type, which is an enumeration. What it says up here is enum game piece X, O. This means that a game piece is a type that can be either an X or an O. And then I'm also saying that...
Oh, wait. Sir.
Sure? Yes?
What does an XO mean?
So, and what does an XO mean? So, it's just a way of saying that that a game piece is a thing that can be either an X or an O. It's our way of saying that when you put something down in the board, it can be either an X or an O.
Unless you're asking how the game of Tic-Tac-Toe is played?
That's possible.
No. So
kids these days know about this game? Anyway.
Probably not.
Well, so because it can be... Sorry, go ahead.
You
can just ignore him.
Okay. Well, so we have this type that can be either an X or an O, and then what we're saying is that the current player game piece is an X, and the next player game piece is an O. What this means is that the piece we're going to put down is going to be an X, and then I have this other variable that's then going to be what's it going to be, not the one we're putting down right now. And then I'm actually going to be changing the on-click behavior a little bit because it's not just going to be putting down the cylinders we made before. I'm putting down a log statement here. I have a console log, putting in game piece, current player game piece. Basically saying, get me the text of what a game piece is in current player game piece, and put it on tile index X, tile index C, which basically means show me the coordinate. So if I click on a block and it puts down an X, in the center it would print in the log putting an X on 1, 1, because remember 1, 1 is the center piece. And so the other change I had to make is rather than just putting down a cylinder all the time, I'm checking if the current player game piece is an O, then we put down the cylinder. Otherwise, then I indented all of that in, and then I made an else, create a box, right? So if the current piece is an O, put down
Oh my goodness.
down the cylinder, otherwise put down a box. And then I do the 3 bottom lines here is to take the current game piece, put it in some temporary storage so we remember it, take the next player game piece and put it in the current, and take the temp piece and put it into the next. Basically just swapping the 2 pieces around so that it's X and the next time is O. And so next up, as you can see here, it's right now you can just put down XO, XO, XO all over the place. We need to actually store this in some data, in some table, so that we can put down the same piece twice in a spot, and also so we have an easy way of checking if anyone has actually finished the table or finished the game. So what we're doing is I'm storing a board state. Is basically, when I say a board state, is the brackets means it's a list of game pieces, and then equals empty bracket means it's just empty to start with. So we have a board state that's a list of empty pieces, and then you can see the board here. Now as you're pushing the buttons on this, the board's going to be filling up, and you cannot push any of the buttons again. The other thing you can see is that as you clicked on these pieces, they stopped animating when you're hovering over them. That's because of the lines that I put in here that says that if this board state, so in the hover enter and hover exit, which is when you point at something and point away from something, if the current content of that is undefined, then you can do the hover. So rather than that, then you can play the start animation grow in. So rather than always playing the grow in, we do it only when a slot is empty. And similarly, you can see in the button behavior on click pressed, is we do the same check if this board state bracket tile index x times 3 plus tile index c, which basically saying that if this slot in my board is undefined or is empty, then is when we do all of this logic for putting down a tile. And then inside that logic for putting down the tile, the very next thing I do is, after you've created the tile, we store the current player game piece, the red line there. We store the current player game piece in the board state at this index. And again, I'm using index x times 3 plus index c because 0, 1, 2, 3, 4, 5, 6, 7, 9. Actually, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8. Man, I can't count today. So next up is now we have the board. You can put down the pieces, but now we need to actually find out if someone won. This can be, for some advanced games, that can be a lot of different checks. Tic-Tac-Toe is very simple to pre-build a table for this because there's only 8 ways you can actually win a Tic-Tac-Toe game. You can go along the x-axis if you get a straight line, along the z-axis if you get a straight line, or a diagonal, 2 diagonals. So 1, 2, 3, 4, 5, 6, 7, 8. So those are the 8 victory conditions. So I made a table that basically just has the indexes of the 3 things that have to be the same. And so this is what my table looks like. So now you can see here, if someone tries to make a game where you win, are we going to have a winner? Yes, we have an X winner here along this row. So this is because it checked in this table. So if you look at the table behind me, you'll be able to see there's 8 lines. Each of them has 3 numbers in them. So the first line, for example, is the 0 times 3 plus 0, 0 times 3 plus 1, 0 times 3 plus 2. So that is the equivalent of a straight line. Now the winning condition here was a diagonal, so it's one of the last 2 ones, which is 0 times 3 plus 0, 1 times 3 plus 1, and 2 times 3 plus 2. So we have these 8 lists that each have 3 numbers. So how do we actually check for if the board state matches it? Well, so after you put down a piece, I have this logic that I created that goes in and say for const victory check of this dot victory check. The for loop again is something that goes through everything in the this dot victory checks list, and then I say that if the board state matches the number 0 in my victory check entry, if that matches what's in victory check, 1 and 0 also matches what's in victory check 2, then we have 3 identical things on a line. We also have to make sure that it's not undefined, as in that there's actually been a piece put down. So that way we make sure there are 3 X's or 3 O's, not just 3 empty spots. So once this happens, one of those conditions is true, then we print to the console log, because for debugging reasons it's easy, right? We print to the console log that the winner is the one that has this game piece. And the second thing is we do update the text here, which is the this.text.text.content. And this.text means the object that we call text. We named this the text object. We could have called this anything like display text or whatever we would want to call it. The second text is because it's actually the text component of this object. That's the type of that it is. And then the contents is the text component has a number of things like a size and some other properties. But it has the contents, which is the actual words that it's displaying. So setting this.text.text.content to the string that says winner is game piece, which in this case is winner is X. So now we have a game. We can play it. We can play it only once, and now you're stuck. That is not something that you can deploy and just keep on running. People will get bored about that pretty quickly. So we want to be able to go back from winning and start again, right? So what we're creating here next is a state machine, which is really a word for what's the current mode of the game, and then make the mode just be either an intro mode, which is attract you to start playing the game, the play mode when you're actually putting down the pieces, and then the celebration mode, which is we have a winner. We do this by creating a type. Again, we make an enumeration game state, which can be one of these 3 types. It can be either an intro, play, or celebration. And you can see here, it went from, there was an intro mode that was there for a second before someone clicked on it. Then people were playing the game, and then you managed to find the bug in it. We'll go over the bug yet. If the game had completed and there had been a winner, it would have gone to the celebration state. But anyway, how it technically works is that there's a game state. There's a game state enumeration, and then we store a variable called game state with little g, which is actually, it's stored as a member of the Tic-Tac-Toe class, what means that the Tic-Tac-Toe current game state is stored there. And then how it's different from before is that whenever you click on something, it doesn't just always put down a game piece. It only does that when you are in game state play, right? Because you only want to put down a game piece when you're playing, not when you are saying I want to join the game. So we do this by checking on each of the game states by using a switch statement. Switch is a shorthand for when this variable matches A or matches B or matches C, then do certain things. So we're saying switch this game state, and if it's in the intro state and you click on something, then we call the function called begin game state play. Basically switch from intro to play. When you're in play mode, things function just like it did before. See, it says when you click on something, you put down the tile. That's what the button behavior did before, but not only happens in the play state. Excuse me just for 1 second.
Just a reminder, everybody, for those of you that don't really know what's going on, this is an SDK meetup, sort of. Soren here is giving us a presentation on how he built a Tic-Tac-Toe game from the new Altspace SDK. For more information, go to developer.altvr.com.
What's the red one? Is it TypeScript?
Yes, this is all TypeScript. Yeah,
Okay,
I'm back again. Sorry about that. I also wanted to change the victory check that we had before. Before I just said this, or set the text and print to the log, but now we're actually just saying switch to the celebration game state. And then at the very bottom here, it says that if you are in the celebration game state and you click on something, go to the intro game state. And this is what the code looks like for each of the different begin game state, intro, begin game state, celebration, and begin game state play. I also had to add this one line at the very beginning, at the very bottom of on start that says begin game state intro, because the game needs to know what is the current state when you start, right? So the code in each of these looks kind of similar. That begin game state celebration, it prints to the log, just for helping us. It sets the state to celebration, and then it prints who the winner is and changes the text to say winner is X, just like before we did inside the victory check. But the begin game state intro is once the game starts or after the celebration is done, it sets the state to intro and it sets the text to tic-tac-toe. And begin game state play, as you can probably guess, it sets the state to play and it says sets the text to game on. And so I would have shown you, if it wasn't because you managed to deadlock here when you were playing, I would have shown you that we needed to clean up the board, because it's not enough to go back to the intro when all the bricks are still, all the game pieces are still on the table. So, so what we're doing next is we have to clean it up. And the best way to do this, or one way to do this at least, is whenever we create a new piece, whenever we create one of these pieces, we store it off in a list, and then whenever we're done with them, we just get rid of all of them. So I do this by creating an array of actors. So technically what it's doing, it's an array of we call it a forward promise of an actor, which is a little bit different. Can we have someone? Oh, so now we actually have a winner here, and you see if you click on this next, it should go back to clear up everything, and I'll show how that works here. If you have a forward promise, it's basically saying that when the actor is created, this is what it will be. Just think of it as storing a list of the actors. And then when we create a primitive, in the code here for when we create an X or an O, instead of just creating it and leaving it around, we're saying, let's push this onto our list of game piece actors. That's what I wrapped it inside the this.gamepieceactors.push. I put a bracket, and then at the very end of this actor create primitive, many lines further down, I have an end bracket that's snuck in there. So this is how we store all of these in the list. And then we need to clean it up again. In the begin game state intro, so basically after you're done celebrating, we're getting ready to play again, we do the whole amount of resetting everything, right? So we're setting resetting the current player game piece to an X, and next game piece to an O, so we always start with an X every time. We clear the board state by setting it to an empty list. Then we go through this list. If there is any game piece actors, then we go through for each of the actors, for const actor of this.gamepieceactors. Go through every one of the actors and say actor.value.destroy, basically destroy me, right? And then this.gamepieceactors, so it clears out that whole list again afterwards. So next up, now we have most of the game here. So I just wanted to make sure that after you're done placing a piece, I don't really like how right now whenever you place a piece, it leaves this giant cube here in the middle. I really wanted it to animate out again. So I just put in this single line that whenever you place a piece, then it stops the grow animation and then just plays the shrink animation. So on the next deploy, you'll be able to see that the piece just goes, or the this box here underneath shrinks back down again. So that was a small little polish item I added in. So this is, remember we had a deadlock before where it just was stuck? Well, it was because we actually didn't have a winner.
Hello.
We had a tie.
What the?
So we got the tie, but we never had a check for if there was a tie. We couldn't put down any more pieces because all of the fields were full, and we could never have a winner because there was no winners defined. So we're adding a simple check for are all the pieces full, and if so, it's called a tie, right? So that's what most tic-tac-toe games end up with, if you know the game just a little bit. So we do this. Let's try to see if we can get a tie here. Anyway, you guys could try to do that. You should be able to see that you can get a tie now, and it's done with the logic that I have up here, where it says if there's just one space that is empty, that means we can keep on playing. So I make this variable that says has empty space and set it to false, and then I go through every one of the 3 times 3 fields in the board state. If any one of those 9 board states is undefined, that means we have an empty space. And so at the end of this loop, if we have an empty space, or if we have no empty spaces, that means we celebrate tie. And so now we can have 3 kinds of celebrations. We can celebrate X, we can celebrate O, or we can have a tie. And I just said, let's just use undefined, as that means a tie. And so inside the celebration, I just added a simple line in that says that if the winner is undefined, we log a tie and we set the text to tie. Otherwise, we print the name of the winner. So, and then it's when you're playing, you kind of want to know whose turn it is, right? So instead of just always saying game on, I wanted to have something that explains a little bit more who should be doing things. And I also did a small thing to stop the boxes from animating when you are in victory mode or when you're in intro mode, because I kind of like that the pieces only show up once you're actually placing them, or the pieces only animate once you're actually ready to place game pieces. So I blocked the cubes from growing in the intro mode by checking for only play the cube start animation if you are in game state play. So if this game state equals play, that's part of the condition for when it can play the animation. So you'll be able to see that here, right? That, well, now you're all busy playing, but see now here, when you're in this mode here, it does not actually highlight anything, any of the cubes. But now once you're in the play mode, then it does highlight something. So the second thing was the text where it said next piece O, next piece X. So I did this change up here. So the first line I put in after, whenever we swap the X and O game piece, remember we're doing this at the very top, put the X in temp, or put the current player piece in the temp, put the next piece in the current piece, put the temp piece back in the next. So swap the 2. After we've done this, we know it's a new piece's turn, so let's change the text to say next piece equals, next piece is then either X or O. Then I also just changed, to make it a little clearer than when you start up when it says tic-tac-toe, that you have to click to play. So that's just adding 1 extra line of text. And then finally I added, when you start up, it says first piece X. I did that inside the play. Like once you first start the play mode, the play state, it says first piece equals something. Just because it's kind of nicer to say first piece is this, or next piece is this. Small little details, but it's part of why it's super useful to have code at the beginning of each state. And so I just made one little more change. As you can see, the text here the text that's kind of above the table, it kind of spins sometime and then it stands still sometime. It's a remnant of something that was left by our old animation system, or by our old Hello World sample, where it played the animation like spinning. We had 4 keyframes for a quarter turn, and then at the end we left it for one more for a while longer, just standing still. So I just removed that last keyframe where it was standing still. The other thing I did was I was tired of the text just floating in the middle, so I wanted to make it float around in a circle like this, as you can see right here. So how did I do this? Well, instead of just having this move around spinning like this, I kind of wanted it to spin around. Hold on, let me see if I can get my second hand track. So instead of it just spinning like this, I wanted to spin it around a center point like this. So this is kind of how it's spinning around, right? So in order to do that, I had to go back to using the same kind of parent relationship that we disabled to begin with, right? We had remember how the cube was tied to the text to begin with? Well, this is kind of different. We're going to be creating a center point to spin around. So I created this that I just called it a text anchor that spins around. And then I did that. I parented the original text object to be underneath the text anchor, or to be a child of the text anchor. So you can see here above, the text anchor promise, or the text anchor is created at y 1.2, so it's in the middle of the table, but offset up to 1.2 meters, which is kind of the center of where the old text was. But then the old text, instead of it being at y 1.2 or 1.5 and z 0, I moved it so that it is at y 0 and z is minus 1.5. It's because it's relative to the parent. So it's relative to the anchor, which means that now it's only offset on z instead of being relative to the middle of the actor, or the middle of the game table, which is where our root is. So this is how I made that change. And then, of course, we had to create that animation before the animation was on the text. So we could have offset it out here, but the animation of the text would have been like this. But we really needed the root node to be animating. So we changed over so that the animation is created on the text anchor, not on the text, and we start the spin animation on the text anchor, not on the text. So next up, there was just one tiny little detail. So there's only one little step left. The whole game is done. There's just one little thing that, if I could just show you guys, if you could stop clicking for a second. So if I just show here, hold on, I managed to soft lock it again. So there was just one bug that was left. Hold on, let's see if we can just get it.
But you're gonna bet.
I cannot get this board to go back to their original state. But what happens is, once you are at the point where you go from the intro to the play mode, the cube that you originally highlighted never plays the grow in animation. That's because the grow in animation is only allowed to play once you highlight something while you're already in the play. But as you're just entering the play state, we just work around this by as you're going into the play state, when we call it begin game state play, we play the grow in animation. And so that's really it. That's how you get the full tic-tac-toe. So that's how I made this game there. And so I just wanted to share.
This was super useful.
Great.
Thank you.
So do you guys have any questions at this point? Maybe I should take a little break here.
We
Steven,
have
can you
time
help
for
with
one or two
clap
questions. Yeah.
emoji?
So let's see, Joseph, you want to go first, right here in the front?
Yes. I played this game before. I'm glad you came up with this game for VR. Holy cow, dude. That is epic. That is surprising me because I played the Tic-Tac-Toe on regular.
This is about as simple as the game can get, but I'm glad
We-
you like it.
We're really innovating here. Breaking new ground.
Wow.
So, anyone else?
It doesn't look like it. Let's,
Okay.
Soren, you have a couple more slides, right?
Yes, I just had a couple of more comments. So the main reason I did this was not to impress everybody with making something new and groundbreaking, but to try to just make something with the SDK. I thought it would be a good way to show everybody how you can make things with the MRE SDK and show the steps that I've been thinking as I was making things, but also for me to learn what are the things that are missing in the SDK. When I tried to make this, what features would I really have wished for? And so I came up with a whole list of different things that would have made my life simpler. I don't know if I should go through every one of them, but I think that most of the things that are here either stuff that we're working on or is very high on our list to work on. For example, right now we have the collision volumes and Animate 2 is being worked on. Materials is being worked on. User input filtering and grab behaviors are really up next anyway. So most of those coming very soon. So I think that's really it.
I have a question.
Sure.
My language is more Visual Basic. Does the SDK allow you to use Visual Basic?
So the question is, this user's preferred language is Visual Basic. Do we support Visual Basic with the SDK? And the answer is that no. Right now, the only languages you can use for the MRE SDK is TypeScript and JavaScript.
Okay.
And it's kind of how the SDK is built up to run on the server. Right now, we run using a Node.js server that's being deployed. So every time you saw me toggle was deploying to the server. And Node.js and TypeScript is really built for that. That's not to say that it would be possible to port some of this functionality over to use other languages, but it's not something that we have right now. But we're hoping that people are going to try this and see that it's maybe not that different. It's not that hard to get started on, we hope. So I would say just give it a go.
Right. Maybe it's not that hard to learn.
So once you know one language, the second language is much, much easier. Learning the first language is the hard part. So give it a try. I think we've given all the samples so that you can at least look at it and try to get started. That's also why in the slides I try to show every single code change, not just the theoretical work that needed to happen. So, any other last minute questions?
Is there anything else?
You did a
How do we find
great
this on
job.
YouTube?
Thank you. So there will be a link sent out on Slack afterwards. I'm sure it's going to be posted on the AltspaceVR channel, right, Stephen?
That's right. Yeah, the AltspaceVR YouTube channel should have this video by the end of the day. And, of course, the source code for this is on our GitHub page. Soren, do you want to scrub back to that first slide with the links?
Yep.
The general information about the SDK can be found at developer.altvr.com.
Oh,
And there are links on there. We'll actually post a link to this tutorial on that site too. But you can find the SDK and the examples and all kinds of stuff on there.
Yep.
So that's your go-to.
So here, there's a link to the slides here. I guess Wait, where's the link to? I don't know where I have the developer.altvr.com, but this is a good link.
Oh.
So. Yep. So.
All right. Well, everybody, thank you so much for your attention. We appreciate you being here.
Well, you're
Thanks for
welcome.
coming. I know
Thanks,
this was
everybody.
long.
Hey, that was what it was all about, you know? You taught us
Thanks,
a lot.
Soren.
Hey, Steven. I had to mute like
I hope some people took some things away from this. So. Oh, I just had one more thing I wanted
many
to try
shreds
to
in
see if I can
Hey, Chris,
drop
what's
it
up?
in.
Is that you calling to
Can
me?
you hear me? Yeah.
Yeah, I
just
can.
had a quick question.
Sure.
Um,
Get out of here. Just kick
totally
them.
not related.
Ugh.
But in